And I'm live. That is pretty cool. Today is 22nd of October 2025, Wednesday. And with that, let's just begin. Today we will write some pipelining code so that we can pipeline the requests, multiple requests which come to our server from clients, hopefully, and which is here, loop, event loop part 2, pipelined requests. And we will also have to see what does pipelining mean, right? What's the meaning of pipeline? So yeah, and also have this new thing, CPU usage and RAM usage, and this just seems pretty cool. And the upload speed 1.6 MBs per second, like very consistent. 1.6 or 7, it is going up and down. And RAM is like and CPU is not being used too much, and RAM is also not being used too much, which is pretty cool, pretty cool. And with this event loop basics, so we did learn event loop basics. We wrote event loop for, well, event loop runs on the server side, and what it does is among the given sockets, it finds the one which are ready to be written to or read from, and written to. And yeah, we just write to and read from the sockets which are ready, and we are not waiting for any particular socket to get ready, right? So that is event loop, and there are two parts of the event loop. First of all, there is the event loop part, which is checking which sockets are ready to be processed, and second part is the what so-called application part in the event loop, which runs the code. So in event loop, like what we did yesterday in event loop, there are two parts. First is the literal event loop part, which uh, finds the ready sockets, or finds the sockets which are ready. That is his whole thing. And then there is the application code. What this does is processes the ready sockets. Yeah, that is the whole thing. The day before yesterday, in the previous stream, we wrote this part, and yesterday we wrote this part again and this part. So that was pretty cool. And I guess event loop basics are now ready. And this event loop is blocking. So when the event loop is running, application code is not running. We are not processing any sockets. So yeah, that is one thing. This is not asynchronous, this is synchronous, what we wrote yesterday. And I wouldn't know how to make this asynchronous without creating external threads, or threads with the same process, or creating new processes, which would just bring back the main problem, which was creating threads and processes is, or new processes, is not very cool. So yeah, with that basic definition of event loop, we will move forward. What we learned in the previous chapter, yep, callback based programming. Yes, reacting to events instead of blocking the thread makes sense. You only process the sockets which are ready, instead of choosing any one socket which you are going to process next and waiting for that socket to get ready, which would like stop the main thread. So it is bad. Handling input with non-blocking IO. Keep data in a buffer until there is enough to proceed. Makes sense. We had two buffers, one for writing the data to a particular socket and one for reading data from sockets, and that was pretty cool. And the boundary between event loop and the application code. Event loop finds the sockets which are ready, and application code processes the sockets. And since this whole thing is running on a single process with a single thread, this thing, application code and event loop, they are like not running at the same time. Either the event loop is running or the application code is running. And how do we manage the switch? Event loop, when it finds ready sockets which are ready to be processed, the event loop calls the application code. And when the application code is done, it just returns and event loop starts executing again. A minimal event loop is still non-trivial. Separate generic event handling from application logic. Separate generic event handling from application logic and persistent application state between loop iterations for request response protocols. Alternate between two states, read and write. Yes, we had flags to determine if we want to read or if we want to write to a socket. Yes, we had flags. And this is the bare minimum you need to know. Then there are more advanced topics to bridge the gap between the toy code and the production software. Shit, we will get to the production software at some point. Shit, okay. So we have done event loop, and that is pretty cool. And also one more thing, I was reading Beats guide for network programming. This thing, Beach, Mr. I think his name is Brian Hall. Yeah, Brian Hall. And this is a very nice book which you could read. Yep, you can buy it if you want. And there is PDF. This thing, shit. Yep, this thing. This is the book. And in this book, he said that there is a function. There are two functions we could use to convert between IP address in string format and IP address in literal bit format. For example, in IPv4, we have the address in like 192.172.0.1 something format. This is the format. I think it is 168 here. This is the IP address of my router, but you cannot hack me if you know this, because this is your router's IP address is also the same. And I think it is, instead of 1, I think here we have 0, because this is a generic IP address, and this IP address belongs to the local network. So all the devices which are connected to my same Wi-Fi, they can use this IP address to send some requests to the router. So yeah, everyone's router has a similar IP address, and I would say not even similar, the exact same IP address. And also there is a function which we can use to convert between this format and the bit representation of the same thing, where we are using a 4-bit integer value, 4-byte integer value. So let's see. Um, the list, let's say, in the master, yep, stuff LCD network, yep. And now we will write a program which will take a IP address like this in a string and give us back the bit representation. But that is very trivial. Instead, what I would like to do is create a socket, get its IP address, and print the IP address in string format. That would be much better. See, print.cpp, and we will have to include some things. Sys socket.h in main, and and yep, and file descriptor again, system af inet, and inet means internet, af is, yeah, inet means IPv4, and sock string for like TCP, and 0 means any protocol, does not matter, and system does not make sense. What we have to do is socket. And after getting the socket, we don't want to bind, we Yes, we just want to, should we don't even need the socket. We just need the address data structure. Net, inet slash n.h. Struct sock adder in means internet, and yeah, adder initially every field is empty, and let us add, or wait, we don't need any of this. What we need is we need a char msg, or let's say adder vector, or yeah, array, and this will have how many characters? This will have 4 characters. Let's say 14, no, not 14. Inet stir len, yeah, inet stir len. I think the value should be value is 16, which is a lot, but anyways, equals empty initially, and we will store the string representation of the IP address in this vector. And for that, we have to call a function which is like inet and inet network to presentation, something like this. Man inet n top, man inet n top. Yes, this is in the ARPANET library. Okay, we can include that. Include ARPA-inet.h internet library, and yes, we will call this function inet inet adder, nope, inet p ton, this function, and we have to, the first thing will be the bit representation of the address that we want to change, and we will say host to network long 0. This is the IP address, and we should, first thing has to be the IP version, which is AF inet. This is the IP version, and now the literal IP. Shit, we cannot just give. I think we cannot give stuff like this. Okay, extraction address of adder and inet adder sterling. No matching function called. Yeah. The function that we are trying to call is ntop. Yep, this one. And okay, this function, wait, this is returning something. Why is it returning a character pointer? That is crazy. Yo, hello. And what we are doing here is, I heard about this function which we can use to convert an IP address from its binary representation to the normal representation like this, with characters here and dots, which you might expect. Yeah, that's what we are doing. And wait, shit. The format has to be like this. N top. That is network to presentation. First is the IP version, which is inet IPv4, and then pointer, constant pointer to source. Okay, so we have to change this second argument. This has to be like an actual address. Struct sock adder in adder. It's initially everything is empty, and then we will say adder sn adder dot s adder equals extend long 0, and here we have to give in the address of address.sn edr header and shell. This thing doesn't, it still doesn't work. Okay. This should be working though. Parameters. This returns, okay, we not capturing the return value is not an error. Okay, the first thing has to be an integer, that is nicely done. The second thing has to be constant character pointer. So we have to typecast this thing and void pointer. Wait, what? Okay, let me look at the book. Byte order, yes, little endian, small endian, big endian. Yep, this one, the sister function of this thing, the reverse, which is this. And okay, we don't have to give out address of this. This still doesn't work. Inet address star length, inet address string length, and constant structure end and AF inet IPv4, the place where we want to store the string, inet and n to p shell. Okay, okay. I was calling the wrong function, my bad. Now we can say with confidence this thing IP address is percentage new line and it is ADDR. G++ print out dot slash out and IP address is 0000, which is nice. Yo, works. Sick stuff you were doing. You this is like actually pretty cool networking. And there is also this part here, and there is a an RFC 1918. This one, and here they are telling us about address allocation for private networks. Like I have my main Wi-Fi, and every device that is connected to that Wi-Fi has a private IP address which is just known amongst ourselves. So we can use those private IP addresses to communicate between the devices which are connected to the same Wi-Fi. That is why when you are connecting different devices, you want them to be on the same Wi-Fi network so that they can talk to each other. And this is pretty cool. Like I can buy some cheap Arduino and attach a Wi-Fi module onto it and put it somewhere and make it do something just by clicking something on my laptop. That is pretty cool. Yeah. SSH onto the Arduino. That would be crazy. I was seeing testing out this function inet n2p, which is internet network to presentation. The network expects the IP address to be in a format like this, like binary format. And if we have IPv4, then the string, then this, and this is like 4 bytes. And for IPv6, IPv4 uses 4 bytes of storage, 4 bytes, and 4 bytes is about 2 billion. 2 billion IP addresses we have because of IPv4. But IPv6, you could expect that IPv6 might have like 6 bytes, but no, they went like bangers, like bonkers with this, and they gave the IPv6 protocol 16 bytes, which is way too much storage to store things. And with 16 bytes of storage, every star in the universe can have 1 million IP addresses. Like every star in the whole universe can have 1 million IP addresses if the universe is like not infinite, that is. And this is pretty crazy. And yep, so event loop is done and pipeline requests. batching requests without caching the protocol. Okay, let's see. A typical Redis server can handle 20K to 200,000, 200K, not 200,000K, 200K requests per second. 200K, that is a lot. 200K requests per second, that is a lot. For simple operations like get, set, and delete, many other request response protocols, re request response applications are in the same range. Okay, and this is limited by the number of I/O events a single thread can handle if the application logic processing the requests is insignificant. Makes sense, makes sense. So when you are asking for some data from your database, if you can uh, reduce the amount of time that it takes for the application logic to fetch the request, if that is very minimal, then most of your time is wasted or is spent only in the IO events. So that is pretty good. And using Redis, which is in-memory database, you are not getting data from the disk, you are getting data from RAM, which is much faster than getting data from the disk, because when getting data from the disk, you first have to get it into the RAM and then onto the CPU registers. So storing the data directly in the RAM is much better. So yeah, the server is bottlenecked by single-threaded I/O. Okay, so it is desirable to increase the amount of work per I/O by batching multiple requests per read. That makes sense. That does make sense. If we are, if like if the server with the code which is running on the CPU, if it wants to get some data, instead of making new syscalls for every read request that comes onto the server, what the server can do is batch these requests and ask for data in bulk, which is reducing the number of syscalls, like literally reducing the number of syscalls, and that is cool. But shit, managing this would be very hard. Managing this would be very hard. This can be done by pipelining requests. Normally, a client sends one request, then waits for one response. A pipelined client sends n requests, then waits for n responses. The server still handles each request in order. The only difference is that it can get multiple requests in one read. It can get multiple requests in one read, effectively reducing the number of I/O operations. Wait, but pipelining on a single client, if every client is just asking for one request, then pipelining will not help. Or maybe we can pipeline multiple clients, not just one client. And we have WW here. Okay, this makes sense. This makes sense here. The total, let's say this, the difference between the top of two arrows is 1 second, and this this like bottom would be half a second from the start. So this thing in total takes 2 seconds, and this thing would take 1.5 seconds. So that is pretty neat. This can be done by pipelining requests. Normally, a client sends one request and then waits for the response. A pipelined client sends n requests, then waits for n responses. The server still handles each request in order. The only difference is that it can get multiple requests in one read, effectively reducing the number of IOs. That makes sense. That does make sense. If talking about speed, then you can use murmur hash 3 if you want maximum speed. Murmur hash 3 for speed instead of relying on the standard hash map for storing the key value pairs for Redis. Okay, why would murmur hash be faster? I mean, okay, different hash functions can be faster depending on how complex they are. Murmur hash. I mean, but here we are not talking about optimizing the IO operation itself. Here we are optimizing the number of IO operations. And yes, this is also optimization, but at the, I would say this optimization is at a lower level, and this optimization is at a higher level in the abstraction layer. And murmur hash. Murmur hash 3 Python. But this is Scala programming language, Apache murmur hash, Apache codec. It is a class. Java implements the murmur hash 332-bit and 128-bit hash functions. Wait, there is no 64-bit variation. RFC. There must also be a RFC for this. Algorithm support. A non-cryptographic hash function suitable for general hash-based lookup. Okay. And what is the default C++ hash function? Okay, there is a function called hash, but what algorithm is it implementing? Implementation defined algorithms. The actual hashing algorithm used by the hash for these types is implementation defined. Okay, okay. So, okay, the C++ standard doesn't say which implementation of hash you should do, but yeah, that is the best part. It is relatively easier. Its hash function is easy compute compared to what we get in speed. That is nice. Following a tutorial, or like, I don't know what how are you doing it? Yes, I'm following a tutorial. Just this thing, building your own Redis, as compared to city hash, which is faster than murmur hash, made by the same guy working in Google, but it's complex, like too complex. And for most of the work, murmur is good. In fact, using city hash. Okay, for small data is slower than murmur hash, so city hash is good for very large data with few collisions. Okay, that is nice. We can use murmur hash if we want to, but where can we get documentation for like what it is supposed to do? They are telling us how we can use the murmur hash, but what is the murmur hash? Docs, documentation. Read the documentation. Shit. Okay, yes. MMH 3. 3 is a Python extension for murmur hash. Yep. Okay, Wikipedia. Okay, let's go. And there were versions, implementations. Okay, there are implementations, vulnerabilities, 2011. When using 128 bits, the x86 and 64 versions do not produce the same values as the algorithms are optimized for their respective platforms. Shit, it is optimized at the hardware level, and this is the algorithm. Shit, you can just write this in a few C lines. That is crazy. And this is the whole pseudocode. They are talking about endianness. All algorithmic is performed with unsigned 32-bit integers. In the case of overflow, the result is reduced to modulo 232. Input key, length, and seed. Seed, okay, this also takes a seed. Makes sense, I guess. See, and that is nice. Murmur hash. It's on GitHub, the implementation for it, and is also available in the Chromium Git source. Shit. So, okay, I guess it is famous. It is the implementation. That is nice. Murmur hash. And the other one you said, uh, the City Hash. Okay, City Hash is the other one, which is made by the same guy. It is more complex but faster, but more complex. It is just the hash functions. Rest of the hash map you need to implement yourself, which is pretty simpler for all hash maps. It's just the hash function which makes the difference. Wait, but the part I have not implemented any hash maps, but the part that I think would be complex to implement would be in case when you have too many collisions and you need to get more memory and copy or and calculate hashes for all the keys and transfer all the values onto the new place in case you need more space to expand the keys of your hash function. That that I think is the more complex part. 1 billion row challenge. Let's go. And it is significantly faster. It gave me out 3x the speed. That is nice. 3x the speed. Murmur hash. Okay, I will keep that in mind. 1 billion row challenge. Okay, we will do that in one stream. Requests pipelining also reduces latency on the client side because it can get multiple responses in one RTR, round trip time. This is multiple requests. Okay, this is a documented use case for Redis. Okay, so pipelining is cool and dropped the time from 55 seconds to 15 to 18 seconds. That is a big drop. That is literally a very big drop. Shit, that is exponential, I would say, in some sense. Requests, pipelining. Okay, so yeah, pipelining is pretty cool instead of calculating or fetching one by one. But this only works when a single client wants to do multiple read operations. So we not pipeline multiple clients. Problems caused by pipeline requests. Pipelining does not change the protocol or server-side handling. Requests are sent in order, server handles them in order, then sends responses in order. So it should just work. Not so simple. Why? Remember that TCP is just a stream of ordered bytes. A server simply consuming messages from it one at a time cannot tell the difference, but implementations often make extra assumptions. For example, when we were doing read handle try one request, yeah, yeah, our assumption here was that we only have one request at a time. And yes, when we wrote this thing yesterday, tmux kill server, tmux set, attach, missed. Okay. And when we wrote the event loop, not the event loop, but the application side code for handling read and write requests. Here, when we are doing this, we are assuming that the client is only sending one request and the next request only comes when we have given the response. So yeah, that was our assumption, but that would not work if we just expect the client to keep sending in requests. Here the client sent a request and sent another request before receiving any response. So we will have to change our code a little bit to make these things compatible. Although there were some else optimizations required, but this was the biggest one since most of the time went to adding reading from hash maps, and most of the cache misses were in it too. Shit, cache miss. Okay, most of 1 billion. You have 1 billion things. 1 billion. 1 billion. And since you already know the size, and wouldn't you need to write a parser too, which would parse the input to see if a user wants to add or read? Yes, the current parser is a very simple one, which and because the current protocol is very simple. It is just 4 bytes which tell the size of the message and then the payload. And here in the payload, we can add our more sophisticated protocol, which would say read, write, or something. The only extension above this basic protocol we have implemented in the client handling side, in the server side, is if the client says exit, then the server exits. That is the only thing we have. And we also wrote a CLI kind of thing. If we run the server, yep, server is listening, and miss ls. And if we run the client, enter your message, we can write hello or hi, hello there, I am the client. Yep, the client says hello there, I am the client, and the server says hello from server. And if we were to write exit, connection close, client wants to close the connection. Yeah, that is the only thing we have above the basic server, above the basic protocol, which is this. About 1 billion operations were cache misses out of 13 billion syscalls. 13 billion syscalls. 13 billion syscalls is a lot. There is a lot, and about 800 million were branch miss predictability. Shit, I don't know what is the meaning of this term, branch miss predictability. And 1 billion operations were cache miss. And how do you know? Okay, shit, you can use that function. So when you are gonna implement that actual functionality, because we are just following this thing, and they haven't s- said anything about a more sophisticated protocol just yet, and we are just going with this. Yeah, we are just going with this for now, and we'll see how it goes. And also, what was that function which we can use for checking things out? Pref, it is used. And let me uh, behold. Shit, I might mess this up. I might actually mess this up. Let us RC. Okay. VM boot. Shit. I should not do this. I should not do this. Wait. Yep. Stop the VM. Shit. Yes. CPU usage is fine. Stream is not lagging. Okay. I have to change the instruction a little bit because in this instruction, I'm giving 4 out of my 8 cores to the VM, which is not very good. But I'm not, no, I am not giving 4 out of my 8 cores to the VM, so that is nice. So here now I can do VM boot to run the virtual machine, and the terminal for the virtual machine is connected to my real actual ghosty terminal. So it is as if I have done SSH into the server and we are talking to the server. Shit, I messed up the password. I messed up the username. All this. Yes, we are inside. Let's go. And yes, I'm now running Linux. You can give me any Linux command and it will work. This is the protocol you'd be using. You'll be TCP to get the data. Now, yes, we will use TCP to get the data or send the data. We will be sending the data. Now, I think after handling the multiple connections, you will need to implement the actual logic of Redis. Yes, which is, I think, in the second part of the course. And look at this. Only 76% of the RAM is being used and 23% of the CPU. I have browser open. I have OBS open. I'm streaming. Virtual machine is running. This is cool. Wait, I guess you can. Why are you on Windows? I would say Windows is such a cluster bloated that I can't even see the performance profiling for the new code. Shit. Okay, there was S trace. Come on. Shit. Okay. If we do have the binaries, okay. And yes, this is Debian, because it has more servers than Arch. S trace H for formation. Now I can use the S trace command, which is kind of nice. I had to do some changes, and the current time is about this seconds. That is pretty nice, but cannot see shit about cache miss or mispredictability. Nope. S-trace is not used for profiling that I want. For checking which syscalls your program is making. I want to see the cache hits and cache miss. Wait, cache, you are calling RAM the cache or the L1, L2, L3 caches in the CPU? Only L1 is in the CPU and L2 and L3 are outside the CPU. L2 is ambiguous, but L3 is outside the CPU. Trace system calls and signals in the simplest case as trace command. How do we give it an executable? Install TLDR. Okay, yes, I thought so. They don't have TLDR. See, the thing is, TLDR, and yes, we do have TLDR. TLDR, S trace might not be, yeah, it is not there. Auto update. It is downloading. Kernel predicts the output of the next instruction and loads output of the next instruction and load things into memory and cache. The frequency used and the frequently used things to avoid making syscalls and same things, all these to increase speed. So the kernel is predicting the output of the next instruction. Okay. Now, if the prediction it was correct, the code would be significantly faster. If not, it will need to remove the previous and load the new one, which causes a lot of time. Okay. Well, I have heard about the that kernel predicts. Wait, I think it is not the kernel, but the CPU, the processor itself. And it is, well, I might be wrong, and it is not predicting the output for every instruction, but output of a branching condition. Yeah, output for a branching condition. Whenever there is a branch instruction, the processor is predicting. So you'll need to write a code which would make the predictions easy. That is why branchless programming is often preferred, because branchless is more okay. I guess the kernel is also doing this, and the processor is also predicting. Processor is predicting which branch the code would go to, and the kernel is predicting what the output of the next instruction would be, and it would be easier for the kernel to predict if the code didn't have branches. And okay, I mean, you can only predict things there if there is more than one path or less. What are you going to predict if the predictability of happening event is 100%? So branchless programming is preferred because there are no branches, so it makes prediction easier, but you know what is going to happen. Okay, we have TLDR. If you have S trace and P path PID, we can give PID of the process, and C does its calls. That is nice. Give us hello.cpp S trace A dot out command not found dot slash A dot out. Okay, these are all the things which this thing is doing, which this function is doing. Okay, that is cool, I guess. I can shut down the VM. Haha, sudo shut down now, and yep, cool. And the CPUs, yeah, I'm like really surprised that the CPU is not being used mm, too much. So that is pretty cool. Although there are some caveats, like modern compilers are smart enough to optimize the instructions for most part. This optimization, I mean, I don't know about much about CPU optimization. I was watching or trying to watch like Friedman Jim Jim Keller, I think is the name of the person. Yeah, he's the one, and he was saying something that the processor predicts where you are trying to branch, and then yeah, branch early, and then if there was a mistake, then go back to the like correct branch. And this is happening at the processor level and not at the kernel level. So that is like crazy. Processor, the hardware is processing things, hardware is predicting, which is crazy. And other problems. Uh-huh. Yep, there were some assumptions. When we wrote the handle read function and handle write, we had assumptions. And the assumptions were the application side code that, yeah, new request, the client only sends data for one request and then stops and waits for the response, and only then after getting the response sends another request. That was the assumption, but that will not happen if we are applying pipelining. So we have to be very careful about how much we are reading. That would require more state to be stored currently. Remember that TCP, and I think since here our current data structure, which is there, struct.cpp, here we are storing the only information we have is the file descriptor, which is necessary. We need the socket descriptor and Boolean values, want to read, want to write, or want to close. And now these two can be open at the same time. Like we also want to write and we also want to read to the same socket. This could happen because of pipelining. In that case, we would also like to have how much we have read. How much we have read would be the size of this vector, but how much do we want to read would also be one thing. That is crazy. And also for writing it is not So we don't have to store any extra information for writing. Whatever is in this write buffer, we will write just that. And this write buffer would be filled whenever we want to, whenever we have processed a whole request after a read operation, then our write would be filled. But we have to make sure that we are not reading too much and we are only reading the amount which we want to read for the current request and that we are not reading too much. Yep. And to do that, in our protocol, we have 4 bytes. The initial 4 bytes, we will only try to read the initial 4 bytes whenever we have a request. Yeah, we will try to read the initial 4 bytes whenever we have a request. And only after getting these 4 bytes, we will process these and we will get the length of the whole payload, which we expect to come after this payload. And yeah, we will just read this much. And whenever we read a part of this thing, we will have a integer called remainder, which will be equal to the length, initially the length of the payload. And whenever we read something, some x amount after this, we will reduce the remainder by x, and we will try to read just this much and put it into our read buffer. That would be nice. Hello. I think as far as I read, it was kernel which was doing, maybe might be wrong. I also have to be like confirm in things, and cause some people use processor and kernel interchangeably. Hmm. And since running the binary is kernel's work, I thought it would be true. It uh, running the binary is, yeah, it is kernel's job. Hmm. Okay, I think we have enough information to figure out if it is kernel or the processor. Does, I mean, if there is a branch instruction, then the processor knows if it is a branch instruction. I mean, if this is true, or whoever it is doing the thing, either the kernel or the processor, they are reading the code or the binary which is being executed. So is the kernel, well, we know that the processor is reading the binary which is being executed. Is the kernel also reading the binary? That would be too much work. That would actually be too much work, I suppose. And however, hello, Turkey, Ankara, hello, how is everything going there? And yes, uh, Turkey, uh, that is the native name. Yep. Yeah, the kernel would not be reading, I suppose, the code, because that just is, I think, making the code slower than it is making faster, because, well, the processor is already reading the whole code, and the kernel, and adding the step in the kernel for, so that the kernel also reads the code, would be too much work and would slow down. Well, yeah, I would have to do my research to make concrete points on this. Reading the code to allocate stack space, although it doesn't, but I don't think kernel needs to run the code. The whole binary is, in my opinion, there is no opinion in this, but according to my understanding, the binary is divided into different sections, and one section specifies the size of, like, how much memory the program is going to use in the stack. So kernel just reads that much and not the instructions themselves to figure out how much memory will be used. And kernel don't think it, yeah, reading the whole code would be too much work for a single human being to do. And okay, pipelining. And shit, kernel also does, not the kernel, the processor also does pipelining, which is crazy. Like it gets, there is a whole 4-step cycle. Fetch, spelling was correct. Fetch, then decode, execute, and store or result. Yeah, there are 4 steps. So when one instruction is in the fetch cycle, when one instruction is being fetched, another is being decoded, and the third one, another is being executed. So that is also pipelining. So that is also cool. And whoever reads, they are pretty smart, I would say. And pipeline does not change the protocol or server side, but yeah, remember that TCP is just a stream of ordered bytes. A server simply consuming messages from it one at a time cannot tell the difference. Cannot tell the difference because TCP is just a stream of bytes, stream of ordered bytes, ordered. Yeah, that is nice, ordered. But implementation often make extra assumptions. For example, this here we are assuming that at most one request is being sent by the client, and here we are writing one response. I think when we are changing or refactoring our code to make this pipelined, in that case we won't have to change handle right, I think. Yeah, I think we won't have to change this code because this is already pretty good. We have a buffer which we want to write, and we can just write it. We do not want to separate buffers for different requests. It would take place on the client side. But when we are reading, we only want to read as much as we need for the current request. We do not want to read too much. That makes sense. So the only difference would be here in this part. And shit, pipelining. Yeah, we can pipeline. Yeah, that would be cool. That would be cool. We can do that. Handle read assumes that there is at most one request in the input buffer. That is why it is blindly reading. Look at this. In try one request, here we are literally blindly reading everything as whatever we could. We are just reading whatever we could, which is bad. Not very good. And handle read assumes that there is at most one request in the internal buffer, input buffer, after it has processed one request. After it has processed one request. There is after it has processed one request, the logic continues with handle write, and after it is done, handle write asks the event loop to wait for more data. So yeah, after writing the whole thing, whatever you want to write, our state for the socket changes from want to write becomes false and want to read becomes true. So we do not want to write anymore. We want to read because we have already written whatever we could. Yeah, which means waiting for more data. Even though there is still unhandled unhandled data in the input buffer. Even though asks the event loop to wait for more data, wait for more data, even though there is still unhandled data in the input buffer. But there is no unhandled data in the input buffer. So the pipeline is stuck because we are making this false. We should make this true. Treat the input as byte stream. To fix this, drop the extra assumption about the input buffer, which is which is to keep consuming from it until there is nothing left to do. Okay, so comment out this and keep doing try one request. This was wrong and this is correct. Okay, after we have processed one request, we cannot just empty the input buffer because there may be more messages. Yes, okay, so we are still reading blindly. Static bool. Try one request. Instead of clearing the whole thing, we just clear the current request. Makes sense. Yeah, that is actually pretty cool. You can do that. We can do that. We can pipeline. YouTube isn't showing my last message. Yo, shit. YouTube's AWS server down, I suppose. In summary, when reading a byte stream, you can wait for n bytes to come, but do not assume that at most n bytes have come, because the byte stream is only about order, not time. Okay, so we are still consuming data like as much as we could. We are reading as much data as we could, but instead, and also when we have one like shit, except handle where is processed payload. Yes, here in processed payload, after reading process payload, we are only processing payload when we have enough data. And when we have enough data, we will process the current request and we will only clear the data for the current request and we'll move on to processing the next request, which is nice, which is nice. Yeah, actually pretty cool. We cannot just empty the whole input buffer, but we will only empty how much we don't need. Whatever we have processed, we will delete that. In summary, when reading a byte stream, you can wait for n bytes to come, but do not assume at most n bytes have come because the byte stream is only about an order, not time. Okay. Test for correctness with pipelined messages. Browsers have tried and failed to use pipelined requests because many servers cannot handle them. Okay, okay, okay. And what would this mean? Browsers have tried and failed to use pipeline requests because many servers cannot handle them. This would mean the browser, if the browser is sending a pipeline request, that would mean we have our browser and it is just blindly sending in request after request to the server wherever it is. Yeah, so this the server is just getting new requests from the same IP address of our device, the browser, and the server might not be able to handle pipelined requests. The server might be configured to just take one request, process it, and clear the input buffer, clear the whole thing, and then give the response. And yeah, the server might not be mm, coded to handle pipelined requests, in which case the browser would be like messed up. Yeah, the input buffer for the browser would, for the server would be like, yeah, some error would come there. The TCP byte stream is a major obstacle to network programming. Why would it be a major obstacle? Byte stream. What we can do instead of this, I mean, we don't have to look at this as an obstacle. I think we can just write code which takes into account the byte stream nature of TCP. That would be pretty nice. I don't think it is too complex. If someone is writing a whole server, then I think they will be able to implement pipelining as a little part of the code in their server. A server cannot handle pipelined requests without interpreting the byte stream correctly. This testing and implementation with pipeline messages can reveal bugs. For example, if the server makes decision based on the number of bytes returned by read, it will fail with pipeline messages. Okay, why is this a problem? A server cannot handle pipeline requests without interpreting the byte stream correctly. Makes sense. Why do we want to interpret the byte streams correctly? Because we want to interpret the byte streams correctly because we want to know in this stream when does a request end and where the new one begins, so that we are only deleting or changing the data which is related to one request and doing nothing with the next request. So this testing and implementation with pipelined messages can reveal bugs. For example, if a server makes a decision based on the number of bytes returned by a read, it will fail with pipelined messages because read is unreliable. We don't know how much things we are going to read, and among the things which we have read, how many bytes in the stream are part of the current request and how many are part of the next request. Hello, good afternoon. Is your laptop back? I suppose not, because this is still Diwali. And bug and tests. Okay. Yo, let's go. S-trace, let's go. We will use this on the VM. Shit, we can use this on the VM. Byte stream handling. The protocol is the same as in chapter 4, but there are more things to test. One is pipeline test. The protocol is the same as in chapter 4. Okay, we are using the same protocol, byte stream handling, but there are more tests, things to test. One is the pipeline test. Okay, pipeline. Okay, so let's make our code pipeline. So we cannot blindly clear everything, which is not really good. Blindly clearing everything is not good. Yeah, and our write function is already pipeline compliant, so we don't have to change anything here. After getting the length here, after reading something, we will insert the thing onto this and payload to get the payload. Okay, and then we are sending the payload and the connection to be processed. So we here do not want to clear everything, we just want to clear a part of this thing. I think we can use the erase function. Connection read dot erase beginning iterator and ending iterator. That will be, let's say, auto reference read equals connection read, and here we can say read dot erase beginning from read dot begin, comma read dot begin plus 4 plus 4 plus how many we want to delete. We want to delete 4 bytes for the size, and then the size of the whole payload, which is str dot size. Cool. This is actually nice. This is actually pretty nice. And here we will do this step always while true. Or shit, what we can actually do is put this thing in the while loop. What payload doesn't exist. It will in a while. Just wait. Here we have the payload string payload. While we have to get the size of the payload, not this. Okay, so we can first get the payload here and here. Instead of if, we can make this a while loop. We will process the payload, and then payload equals parse connection read. We will try to uh, like read the next request, and yeah, we'll try to do that. That is nice. I think that would be all. Here, instead of just responding to one request, we are responding to multiple while we have enough data to do so. And also, when we are processing the payload, we are not removing everything from our read input buffer. We are just removing the data related to the current request which we are processing. So that makes sense, I guess. It got repaired. I will go in the evening to take it. Yep, let's go. Let's go. And you just again be coding. That would be nice. And now we have to do some byte stream handling, debug, and testing. The protocol is the same as in chapter 4, but there are more things to test. One is the pipeline test. We have to do some pipeline test. Query list. And for each query, we are sending the request. If error, then do something with the error. And after query list, shit, we are just sending the requests. We are not receiving. We are receiving data here. Okay. Read res. Okay, that is cool. So, okay, this is going to be on the client side. Let's do this query list. Okay, and then for each string, we are sending the request. Yes, we are just sending the request, and we are assuming that our read buffer, which has the response which we get from the server to which the client is making the request. We will just keep reading everything, and we will process data from the read buffer. Okay, the server is likely to receive multiple messages in one read, which tests the parser. Okay, okay, shit. We are testing our code. We are testing our code. That is pretty nice. Wait, that's miss. Okay, we have modified one thing, and let's say we will write a new function, and we call it pipeline tester .cpp. Say Tokyo night has update, which is crazy. Yeah, sync. That is nice. Uh, include std. Okay, and I think we should write some general functions which can be used by any applications. General.cpp, and this would include a function that takes shit. We already have a similar thing, format.cpp. Yeah, read all, nope. Parse length, this takes in a message and gives us the length, and write length takes a message and writes the length. What else we can write is a thing which takes the string and converts the string into the format which is required, which would be in interactive client code that we wrote yesterday. Okay, write to, this takes in a string and a file descriptor. So we can just, and internally we can use memcopy to copy the string onto the buffer. Okay, in the format.cpp, we can write a new function, static function, void send request or format stir. This takes in char pointer. Yeah, this function takes in a char character pointer to a string, and that is kind of it. Yeah, that would be it. And this will not return void, but this thing. Wait, I think I should also take a character, another character pointer, and also the length of the initial pointer. In which case, I should make this thing string s. Std string s, and this thing will return void. String s and char pointer src uh, destination where we want to store this. So first we will get the length. Length is s dot length, and first we want to write the length somewhere. For which we will call the right length function, just from like right here. We have the right length function. Right length, first thing would be the length of the string size which you want to write in the correct format in the destination. And now we will use memcopy, and the destination is going to be des plus 4, because the first 4 bytes in our message are taken to store the size of the string, and the second has to be the data, which is s dot data, and the size of the data, which is s dot size. Yeah, that is kind of it. Yeah, yeah, should that is literally it. Format string. This function takes in a string and where to format, and just formats. Yeah, that is nice. We can do some changes. Sterling message. Yep, we can make this std string. Sterling, we don't need to do Sterling anymore. Instead, we can substitute sz with s msg dot size. Yeah, substitute sz with msg dot size. Hey, there is some mistake here. Struct application. This is in the application side. Nope, this is in the interactive client. What the integer has to be of type size p, so we have to size p type class. This is still not good. Yes, this is of course wrong, because substitute sz with msd dot size and with substitute sz with msd dot size, and instead of bare message we have to say the data, which will give us the character pointer which is on the heap, which is actually storing the data. So yeah, that is kind of nice. So memcopy and write to. I think this function is better than the one we are writing in the structure, in the helper, in the format.cpp code. Yeah, what we have in the interactive client is already better. Okay, and we can remove event loop from here. Structure application, we are not doing anything with the application. Struct form, we are not doing anything with the struct. Should I add an event loop? Interactive client. Yeah, cool. This is the format, and shit, yes, we don't need this. We don't need this. What we can do is we can make this function uh, delete from here and write this here. Max buff, that is a nice thing. Const int max buff equals 64 into 104, 102, 1048. Unknown type const, and there is no error, so that is nice. That is nice. Okay, this function is okay, and we can do the same with read from. Do we want to do the same thing for read from? Here we have file descriptor, and we are reading max buffer, but we are only reading once. And if we don't get the whole input string in one go, we will just stop reading. So that is not very good. We create a buffer to store the thing and parse length file descriptor. Makes sense. Parse length function goes to the reads like 4 bytes from this file descriptor and gives back the length. And I think parse back function is has a loop. No shit. This does not have a loop. Okay, shit, that is not very good. Int rem equals 0 or rem equals 4, and while rem keep reading, and this is non-blocking. Sorry, this is blocking, but we can afford this to be blocking because this is on the client side. We don't care about the client. The client can be blocking, non-blocking, whatever, does not matter. And the thing that we want to read is rem. That is how much we want to read, and from where we want to read plus 4 plus 4 minus rem. Rem is 4, so we will start storing from the first location in this. And if rem is, let's say, 2, only 2 things are remaining, then we will start storing from the second index. And if rem is 1, only 1 byte is remaining, and we want to read just 1 byte, then we will store that at basic length plus 4 minus 1, which is at index 3. So that is 0, 1, 2, 3, index 3. Yeah, basic length plus 3. So yeah, that would be cool. And after reading 4 bytes, we go here and yeah, we parse the length and we return the length. So that is nice. Okay, so parse length function is now blocking but correct. And yeah, length cannot be greater than the maximum buffer size. And read all. Read all is already pretty cool. Read all is already pretty cool because it has a while function, while call internally, where n is the number of bytes that are remaining, and yeah, till we have something to read, we will keep reading. Yeah, so that is also nice. And we all, and the caller is giving us the place where we want to read. Yeah, we are giving to the read all function the file descriptor from the socket descriptor from where we have to read, and where we have to store what we read, and also how much we have to read. So this is also cool. And yeah, now the question is, Do we want to make this a like general function and move this into a separate file so that anyone can call this function read from? And I think that is something we can do. But how is the write to function? Write to function is creating its own buffer where it is going to store everything, and it is writing the string. And that is nice. The client does not want to read this buffer. Yes, which is nice. The client does not want to read this buffer, but for the read function, we do need the buffer. So the buffer has to come from the caller character pointer. Let's call this r buff, and we can move this line from here to the caller and pass in r buff. Okay. And now we can move this, but return 0. In case of error, return -1, which is pretty nice. Yeah, we can move this function somewhere else and read from. Is this like pipeline compliant? Read from. Yes, we are only reading as much as we want to read. Read all. Yes, we are only reading this much, even though this shit. If we have the opportunity to read more data than the current response, then we should read it. Hmm. Okay, shit. Okay, we are messing a little bit. We can work with this because the only bad thing that is coming out of this is a little latency on the client side. And that is fine. That is fine. That is fine. And the problem with this is that the client is only reading as much data as it needs to process the current request, because we are only calling this read all function when we have the length for the current request, and we are only reading the payload for the current request. But since the server keeps sending the responses for all the requests which the client has sent to the server, then we might have data, we might also have data which belongs to the next response. And in that case, if we have more data than just the data related to the current request, in that case, we should read more data and just not process it right now, and we can process that data later for the next request. But that is not what we are doing. We are just reading as much as we need, which is a bit slow because we are doing more read operations, but this is not very bad. This is okay. Okay, after reading, stir exit, and enter your message, write to and read from. After read from, printf server says, or shit, yes, server says. What does the server say? Server says rbuff. That is what the server is saying. And yes, that is nice. That is nice. Okay, this is cool. And now, yeah, this is cool. This is cool. This is cool. This is going to work. Yep, this is okay. And we can move this. Yeah, we can move this into a general function so that Everyone can use this. And okay, there is no error here, at least. That is good. Client request, max buff, redefinition of max buff. Yes, we don't want to define max buff here. Okay, let's, yeah, format.cpp has the definition for max buff, so that is nice. And here we don't even want to do this. We will just take in the message and we will write it. Write all, no, write to is the function which we can call here on the client request thing. Write to no matching function calls. Yes, the format is this. First thing, the buffer, and the second, first thing is the file descriptor, and second is setting, second is the message that we want to send. Include string. That is nice, and given the file descriptor and the message. Okay, we can write with that. We don't even have to do all of this and none of this. And for reading, yes, we will create the buffer. We won't get the length. We won't call the read all function and anything here. We will just call the read from. What is the name of that function? Read from. Read from where we have the file descriptor and our buf where we want to read, and then how much. No, just that, just that. Yeah, this is like much smaller than before, which is pretty cool. Now what we will do is in our interactive client code, we will make this pipeline so that we are like here, we write to the server and then we read from the server. What we want to do is write a bunch of things and then read a bunch, like read all the requests, all the responses. So that is what we will do, and we will create a new file, test pipeline, or like we already have pipeline tester, includes this socket.h and main end file descriptor for the server, socket af inet internet IP version 4, and we will use a TCP connection for this with any protocol, does not matter. And now we need struct sock adder in internet socket address for the internet adder. Initially everything is 0, and we have to include a few things. That is include net inet in.h. That is nice. And then we will populate this thing sn family. Family is af inet, which is IPv4 using 4 bytes, and adder sn port where the server is running, that is host to network long, the port is 1234, right? And then adder sn adder dot s adder socket adder. It is HTONL host to network long, and the address is sock adder reuse. Shit, I cannot remember the name of the thing. Interactive client, let's see. pipeline tester, in adder loopback. Okay. In adder loopback. Yep. That is what we need. And yeah, now we can just start the connection. Int n equals connect this file descriptor to struct sock adder in pointer, sock adder pointer. The address of this structure of this address should address of address. Yes, we have to give an address of address and then size of adder. Cool. If n, that means we got some error, p error, and connect to the server. Yes, after we have connected, and also we will exit after this if we were unable to connect. After we were able to connect, then we will do something. Yes, Rust is going pretty cool. Yesterday I read about mutability, and there are basically just 3 rules which the Rust compiler makes sure are always there. Every value has a master, you could say, or owner, and then second, every value has only one master, or let's use the general term owner, and then third is that also that when master goes out of scope, value is freed, like value which is the memory which is storing the value, it is freed. And also there is the thing about references. There are 2 kinds of references, like normal, borrow references, which just use this ampersand, and then there are mutable references which use ampersand mute. And the thing is, we can have multiple of these things, multiple of borrowable references at the same time, and what we cannot have is multiple mutable references. We can only have one mutable references, and mutable references are able to change the original value which was given to them, and not just, yeah, that is it. And borrow references are like simply read only. They cannot change. And when you have a mutable references, you mutable reference to some variable, you cannot have borrow references to the same thing at the same time. And the scope of these things are, it starts from where they were declared and it ends where they were last used, not in the scope in which they were defined. And what I said that day about the error, nope, I didn't try that because I haven't gone into the pointer thing. I'm just following the book, the Rust programming language. They haven't said anything about the pointers. Now that you've read it, I think you must have understood what I was trying to say that day. You were saying that a mutable pointer has a reference. A mutable pointer is a pointer which can change the value it is pointing to. Shit, maybe by pointer you meant reference, and if you meant a reference, then it is true. If you have a mutable reference to some variable, you can change it, and that makes sense. Shit, yes, I think if you meant mutable pointer instead of references. And I don't even remember the whole thing that you were saying because I had no mental model to store it. Just created a mutable reference, mutable variable, and create a new variable, which is the mutable reference of that variable. Yes, yes, makes sense. And when you have mutable references to some variable, you cannot have normal references to the same variable, like borrow normal references to that same variable, which also makes sense because if you have a read only variable to something, you do not want its value to be changing anywhere else, right? That would be kind of bad. Try printing both. My main thing was about the printing error. Wait, we cannot print them both? Huh. Hello, dot. Hello, source main.rs and shit, yes, some testing going on. Let's say you do have let x equals string from hello there, and we can make this mutable, and we can have let y equals reference mutable to x. This thing works. Yeah, this thing works. And now print ln print x. Okay, this is working, like at least no error. Print y. Cannot borrow x as immutable because it is also borrowed as immutable. And if we print x here before we make y, okay, we cannot use them at the same time. The thing that you were saying, mutual borrow used later here. Shit. Okay, what is the exact error? Cannot borrow x as immutable because it is also borrowed as mutable. Shit. So when we have when we have y here, so y is now acting as mutable x, but mutable reference to x, but x is, I suppose, acting as a normal immutable reference. Hello, how's everything going? Shit, this is crazy. Let's see the whole compiler error. Cargo filled. Okay, here mutable borrow here. Cannot borrow x as immutable because it is also borrowed as mutable. Shit. This makes sense. This I think makes sense because when we are sending the x function to print ln, we are sending a immutable borrow here. And then later on, we are using the mutable borrow y to change the value. It does not matter if we are changing the value or not. We are using it. That is the main thing. If we change the order, I think that should help. Shit, Rust Analyzer broke. Now it compiles because yes, the scope of this y variable starts from where it was first declared and the line where it was last used. So this is correct, but this thing is wrong. This thing gives error because here we are using x as immutable reference and later on we are using y, which is a mutable reference to x. So now it makes sense. And this shit, okay, okay, exclamation mark here means that a macro, exclamation mark is a macro, happened as soon as I decided to dedicatedly restart learning Rust, and boom, initially got into a fight with the compiler. But the compiler is like a very nice fighter, I would say, respectful. He tells you everything. But the thing is, didn't Rust just said that we can have infinite immutable references to a variable, but only one, but not at the same time. It is like written also in the book in this part or ownership, references and borrowing. You can have infinite number of immutable references, but when you have a mutable reference, then you cannot have any immutable references because at a meta level, like the structure, this would mean that immutable reference is a read-only value and mutable is also a write value. And when you have read-only value, you do not want your value to be changed, right? The value which you are reading from. So does that mean we cannot pass the reference of a variable to a function if you have no, you cannot do that. But the scope, if the scope of the mutable reference is not with the scope of the function where you are passing the immutable reference, then it is okay. Sometimes pass the whole value to a function and then change the value as a pointer. You can do that in C++, but not here. Just add a and before the variable, after the type of the variable, and you're okay in C++, but not here. Okay, here we are saying we are sending S, and wait, why is there an error? Cannot be borrowed as mutable. Shit, okay, that makes sense. This is immutable, so we cannot do this. And mutable references, yes. There was a maybe a line at the end dereferencing the rules of reference, yes. At any given time, you can have either one mutable references or any number of immutable references. That is the main thing. Hello, how is everything going? Yeah, and that is what I hated about it. Oh, you just have to be more rigorous with Rust and think about what you're doing. That is like brings you into shape, makes you sharper, I would say. It is not exactly freedom or code style I am getting. It feels like I need to learn about the language then logic. I mean, yes, but if you want freedom, you can go to C++ and literally write your own language almost with classes and everything. You can, yeah, you can define your own syntax even in C++, override operators and everything. So, yeah, and references must always be valid. That also makes sense. And going back to this thing, Tmux is amazing. We can just switch, which is nice. Yes, after making a connection, what we will do is send a bunch of requests and parse them by taking concepts from functional programming, procedural, and OPP to trying to amalgamate, trying to be amalgamation of all. Better is better than none. Yes, that, and to avoid this kind of problem, Haskell has a amazing motto. Yep, this one. Avoid success at all costs. That is their motto. It means, or like it is supposed to be interpreted as do not go after success at all costs. Like C++ does. C++ wants success in everything. So C++ has implemented everything possible. And yeah, so Haskell does not want that. Haskell says avoid that kind of behavior. Do not be best. Do not try to be best at everything. Be who you are. Yeah, that is Haskell. And yep, now we have to test our code. Pipeline tester.cpp. You will have a vector of string, and we will say messages, and it will have a bunch of strings: first, second, third, and for auto s in messages, we will we also need some helper functions. CPP. And wait, what was the functions? We have to first, yeah, we'll just write to our file descriptor all of these strings. Write to fds. Cool. Yep. So we have written everything, and after writing, we will read. And also, wait, is the write to function returning some error? No, it is not. Return write all. And what is the write all function returning? Write all function is returning error in case of error, so that is kind of nice. And yeah, that is kind of nice. Write all int n equals write to, and if error, then print error, can't write the whole thing. Okay. And yeah, after writing the whole thing, if we were able to exit code 1, if we were unable to write something, and then we will try to read the whole thing. For we have like the number of requests is the same as the number of messages which we sent. So msgs, and the function for reading is read from. Read from this buffer, this much length, and yeah, this is okay. This will not cause problem if our buffer has more data than what is related with the current request. So that is nice. And yes, so we have to first create a buffer, read buffer of size max buff, max buff. Initially everything is empty, and read from this file descriptor r and okay, int n equals this thing, and is this function returning error? Yes, this is returning error, so that is also nice. So if error, then the error cannot read all the requests, and if this happens, then exit. Otherwise, printf server says %s new line, and the server says rbuff. That is what the server is saying. I think that is good enough. This pipeline tester code, yeah, not clear G++. Wait, what is our pipeline server? Pipeline, we have the pipeline tester. Event loop, yes, our event loop is now pipeline compliant. Output server, it does compile, and G++ pipeline tester output client, and error because we are using memcopy. Why are we using memcopy? We should not be using. Yes, it is in the flow format function. Yeah, to include C string. Now we should be okay. Yep, we are. We run the server. Server is listening. Not slash client. Client says first, and then yeah, then error. Then nothing happens. So the server is messing things up, I suppose. Yeah, server is not handling the requests correctly. Event loop dot be this has to be from application side handle read. Yeah, handle read, and let's say after we do read the whole thing, parse. What is the parse function doing? Parse. The parse function is just returning a string, the payload. And maybe this might be just going a bit too much. Get length for read.data, which is nice. Okay. Okay. And then if len plus 4 equals read dot shit. Yes, we have to make more changes. Shit, my bad. Okay. Yes, if we know that we have enough data to get the length, we will get the length. And not just this thing won't always be true. Uh, yeah. If we have the data that we have is greater than or equal, the data that we have read is greater than or equal to the data that corresponds to this current request. If that is the case, then we will put that thing into the response and we will return it. Okay, that does make sense. And after that, handle read, if we do get the payload, we are processing the payload, and then payload equals to pass. Yes, that makes sense. Processing the payload. In processing the payload here, we are saying want to read. Nope, no, we should not do that. We always want to read. Read dot erase. Yes, erase, and then stir equals exit. Makes sense. If we want to exit, then we will exit, and want to close, we will make want to close true. Wait, shit, we can just make want to close true because we might want to write some data. But this thing would only happen if we are at like the last request. Okay, so we will hand, yes, if want to close is true and we do not want to read and we do not want to write, only then we will close the connection. In the event loop, we are closing the connections here. If want to close is true, or there is some error with this socket, if any of those things, and we do not want to read anymore, want to read, like this has to be off. Only then we will do this, and that should be enough, I guess, for the server. Compile the server. G++ pipeline tester dot slash server, run the server, missed dot slash client for a second. Okay, we got to the second part, but we messed up with the third part somehow. I think we can fix that if we change the third string to exit, so that we will exit. Makes sense. Yeah, makes sense. Makes sense. G++ event loop was already compiled. Uh, pipeline tester dot slash client and still the same error. Yeah. And I'll be right back. I have to go to the washroom. I'll be right back in a minute. You back, and you said you are in initial years of your college. I want to know, how do you get these plans, ideas, or roadmaps to do these things? I'm in my third year, like fifth semester, and like, how do I get these plans? I thought I don't know about Redis, and there is this page which teaches me how to build my own Redis. So, okay, let's go. And also, uh, yes, since I am now here working with Git, right? Git master. So I want to use the full capabilities which are provided by Git, and therefore I have begin retaking the course on boot.dev about GitHub, about GitHub. This is the first basic course, so which is pretty cool. This is by Primogen, so yes, and I have taken this before, and I like editing 75 editing lessons. Okay, and so I just have to cruise through this. Now this won't be too difficult. I just want to revise everything about branching, merging, because since I am using it here, so I like I should know what Git, how it is working. And they, in this course, they also tell about like internals, literally internals. There are plumbing commands and porcelain commands. Porcelain are the high level commands which people use, like git push and things, and plumbing commands are low level commands like assembly commands, where we are actually interacting with the objects in the git. So yeah, and so do git, do this course. That is how the plan is. Yep, let's go. And shit, there is some mistake. Connection reset by peer, connection reset by peer, both of the connections, because we ran the code twice. Let's run one more time. Okay, first and second, so that is shit. No shit. And event loop. Okay. I think on the event loop side, everything is pretty cool. Everything is pretty cool. Everything is pretty cool. I think the problem is coming from how we are changing the state, whether we want to read or whether we want to write. Yeah, how we are changing state. Yep. Shit. Okay. Okay. I think I got what the problem is. Client request. No. Application. Here. Handle read. When we are processing the payload here, we are saying, okay, client says this, and we want to read. Yes, we want to read. And we are saying the write equals this thing, which is wrong, which is no. What we have to do is append, which is not the right function call. Shit, how do we append? We'll just do plus equals. No viable operator. Huh? No viable overload to this thing, even though this is a string, and get response, get res returns a vector. Shit, it returns a vector. How do we concatenate two vectors? How to concatenate two vectors? C++, insert at the end. Okay. Insert, and what is the syntax? Yeah, insert at the end. Okay, cool. Con write dot end insert. Shit, okay, let's say auto s equals get res with hello from server, and also we will get auto reference write equals connection write with vector, which is storing the connection, which is storing the byte string that you want to write. And on this write, we will call insert right at the end of this insert, beginning from s dot begin and going till s dot end. Write the whole thing. That is much better because before, when we were writing a new string, when we were processing a new request, we were overriding the older write buffer, which is not very good. And also, when this is there, then want read equals false. Wait, we don't have to do this explicitly. We will say we don't want to read when the client says we don't want to read. Otherwise, we will just always try to read. And in handle write, when we have written everything, then we will say nope, no need to read anymore. Shit. We don't have to bother with the read state in here. Yeah, it doesn't matter. It doesn't matter. This write will only become false when we are not writing anymore, when the write buffer is empty, and read read will only become false when the client says exit. Okay, but the write flag initially is false, so we have to make it true here. Yeah, we have to make it true here. So we will say connection want write equals true. But if there is nothing to write, then want write will become false. And yes, after this line runs, we won't be reading anymore because yeah, we will just close the connection. We don't have to read anymore. And here, what if this thing is empty? Sure, we do not want to call write function when we have nothing to write. So if connection write dot size, if the size of the string that you want to write is 0, then we will say connection want write equals false. Yeah, we don't want to write anything if there is nothing to be written. Makes sense and should work, hopefully. Event loop output server. Okay, it is at least compiling. Clear miss and don't run the client just yet. First the server, then the client. Okay, there is some mistake. First, second, and then nothing. Pipeline tester. Let's. What if we add some more strings here? Third, stop. G++, pipeline tester, run the client, and for a second, okay, we are not getting the third one. We are not getting the third one. Why? Application side code get length. Whenever our parser is running, we will see what is the length that we are getting back. Here is the parser length. Okay. Length. G++, event loop, output server, clear, go to write, go to the project, here, run the server, run the client, and okay. For the first thing, the size is 5. 1, 2, 3, 4, 5. Makes sense. For the second thing, the size is 6. But then something crazy happens. The size is this much. Okay, how do you... What is this? Hello. I also want to start competitive programming. Can you help me with this? To just tell me some beginner things like guides and how to start. Yes, of course. Of course. I have seen you do, yep, I have done a little competitive programming, like a guide for Redis. Is there any guide for competitive programming? So when you are beginning competitive programming, you need two things. First, something to get the theory, for which we have this, and some place to get questions from. So for questions, you can go to this website, tleeliminators.com, CP sheet. They have this sheet called CP31. You can go there and start solving questions from 800 rating. Yeah, start solving from questions from here and keep going up, right? That is nice. And also you can use this book for theory. This is a pretty nice book. You can just look up CP handbook And the first link by cacs.fi. Fi is Finland. And yes, this is the same book, CP handbook. You can use this for theory, and you can use this CP31 sheet for questions. And if you need like a more in-depth guide, there is a post on Reddit. uh, Competitive programming, and yep, this one, a guide to competitive programming, CS majors. The user is like deleted, dead, and you can read this. And this is also pretty nice. This post has resources and yeah, just generally how you should learn and how you can learn if you want to get into competitive programming. Yeah, that is nice. You can use this. And shit, that website was still loading, but yeah, this book is pretty nice though. And I would say you can read at least these 4 chapters just in sequence. Yeah, that would be nice. That would be nice. And after reading these 4 chapters, you can read the chapters either like in order, does not matter. After that, you can read chapters by depending on the topic that you want to read about. If you want to read about graph, you can just go to graphs, or number theory, you can go to number theory, combinatorics, anything. Yeah, that would be it. You're welcome. Iron Man. Insert is here. Okay, so the length is messing up, but why is the length like this? This is okay. When the client exited, we messed up something. Okay, why was the length this big? It doesn't make sense. Let's see. Let's see. On the application code, what we can do is the string, the raw string that we are reading, we can print that. Yep. Here, after reading, SVC out, connection, read, buffer, line. Huh? Okay, shit. We have to change this from unsigned integer vector to something else. And shit, now I can use my competitive programming skills here. Yep. There we go. Shit. No, did you mean okay? We have to change the type there. This is a like snippet I wrote so that I can print vectors, and here what we want to print is a vector. So that is pretty nice. And what we can do a little change here. When we are outputting this thing, we can say typecast this into a character, which is pretty nice. Yeah, this should work. Not work, but we will be able to see the error at least. Run the client and okay. Okay, shit. This is like crazy. Okay. We read 3 bytes in the first try, okay. But then we read 1, 2, 3, 4 bytes. Yeah, we read 4 bytes, then SE, then we read 4 bytes, and SECOND second, and we read 4 bytes second, okay, and then we printed, literally we printed second, nice, and then THIRD, okay, we deleted more than we were supposed to. Yeah, that is the problem. We deleted these 2 things also, which is bad. Yeah, we deleted these 2 things also, which is bad. That is the error. Okay. And yeah, we deleted more than we were supposed to. How can we fix? Why are we deleting? We are only deleting here when we are processing the request, processing the payload. Yep. Here erase from the start, delete till 4 plus stir length, where stir is the payload which we just read, which would be like second, 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 and size. So this should not be a problem, because this is not the problem when we are processing the first request. So yeah, this should not be a problem, but it is a problem somehow. Erase all of this from the beginning till that point. Erase read dot erase. From read, erase. And we do want to write. That is nice. We are erasing more than we should. Yep, we are erasing more than we should. Okay, let's also print whenever we are processing a request and not handle read. Here when we are processing a payload, before or yeah, after erasing, we will see how much we are erasing str.size. We should still be erasing like the nice only as much as we wanted to, because when we are printing the string here, we are only printing second and nothing extra. So yeah, and let's see G++, or maybe there could be some error in pipeline tester. Here we are calling the write to function again and again with this string again and again. Okay, which is right here, this write to function, and this function is creating a buffer every time, which is nice. And then writing, so there is no problem in the writing part. That is pretty nice. Yeah, this is pretty nice. In the first 4 bytes of this data, we are we are writing the size of the data, and then um, from there, after that, we are writing the message, the literal message which we want to send. And that is nice. And then we are writing the whole data to the place where 4 plus message dot size. Yes, yes, that is also nice. And then read from this socket. And yes, keep in mind that our client is just unable to read anything. Len equals parse len fd assert length smaller than max buffer, then read all. Yeah, this should have worked. In pipeline tester, okay, let's go. Event loop outside output server. clear, run the server, and run the client. Client says second and 8. That is wrong. That is wrong. That is wrong. Second, that is not 8 bytes of space. Shit, yes. So the string that we are sending is kind of messed up. Yeah, the string that we are sending to be processed is messed up because we are removing more than we should. Here in the process payload, the size of this string is 8. second. It should be 6. That is why we are removing 2 more bytes, and we should not do that. So why is that happening? The string that we are getting is 2 bytes extra than this function should be getting. And the size of this string is given. Yep, the size of this string is given to us by this parse function. Okay, by this parse function, and it checks if there is less than 4 bytes. Okay, and then see out length of what we have read, of how much data this payload is. Makes sense. Okay, and then we will also output the payload, let's say. Okay, G++ event loop output server clear, run the server, run the client, and okay. So this is nice, but we removed too much. We removed too much. We removed too. Wait, res is a string. Okay, makes sense. Res is a string. Res is a string. Makes sense. There's event loop. Nope. There it is with pipeline tester. Remove pipeline tester. Yeah, go to application. This length is right. This length is correct. So there is no problem with this parser function. We are getting the correct payload from this parser function. But after getting this payload, while payload dot size, after getting this payload, we are facing difficulty. Here, the size of this string that is coming here is not the same as what is the payload sending. And the payload is sending a string. And here we are saying, yeah, take read, want to write is true, and erase begin, read dot begin 4 plus str dot size, which is also right. Let's say cout std standard cout read. Yes, and std standard cout and line std end line. We don't have to use end line here. We can use it on the next line. And here we will say length is str.length or str.size, and also a space and then the string itself. Maybe this string first and then length str.size. Okay, G++ event loop, compile, run the server, go to write, go to the folder, run the client. Okay, second, and length is 8. How second second, that is not 8. How is this thing 8? The size is wrong. The size is wrong. Off by 2 somehow. The size is somehow off by 2 process payload. So at this point, we know that the size is wrong somehow. Yeah, we know that the size of this string is wrong, even though when we are printing this string, literally this string, we are only getting second, and there is no extra buffering, and then we get len length. So there is something internally wrong. Maybe this erase function is messing things up. And okay, this process payload function is called from this place, and we can literally see the payload. Let's see. std out payload length is payload dot size, and payload is payload. Yeah, std and line event loop, run the server, clear, run the server, write, run the client. Payload length is 8. Why is the payload length 8? Huh? Payload length is 8. Payload length is 8. Okay, that is wrong. second, that is not 8 characters. Okay, so payload length is wrong. Let's see what the parser was returning the correct thing. So let's just check once more just in case. After returning, instead of payload, we will say substitute payload by res in the whole line. Event loop, outline, output server, run the server, go to the folder, run the client, and res length is 0 for a lot of things. But before that, res length was equal to 8. Okay, that is wrong. So the parser is messing up. Shit, the parser is messing up. The parser is messing things up. Okay, and the laptop is going to die. We have to fix the parser, but why would it? Why would the parser mess up? Here we are initializing rs equal to 0, and let's see the length which we get. Okay, no, shit. Okay, let's see what the parser is getting. Yeah, let's see what the parser is getting instead of just blaming the parser. Yeah. Yes. First, we will print this read buffer which we are getting. Then we will see the length and all of this after this. Then we will print out res. Then we will say length is length. Yes, and then we will say space res size is res dot size and std end line. Uh, yep, compile the server, clear, run the server, run the client, and okay. Okay, this is what the server got for the first time. Length was 5, but we didn't have anything, so we didn't initialize our response. Here, the length was 5, and we did have 5 things, so we initialized our response and we returned our response. So that is kind of nice. And then the length was supposed to be 6, which is nice, right? And it was at this point. I think we are reading the whole thing. I think we are reading the whole thing till here, till the end of this. And that is like, what's wrong? Kind of wrong. Let's see how the parser is filling this. Shit, yes, yes, yes. Okay, okay. I do see the mistake. Here, we are starting from the start of the payload for the current request. Yes, so our starting point is correct, which is the start of the payload for the current request, but our ending point is going to the end, which is not right. Begin plus 4, that is the starting point, plus the length. We do not want to include length. Yes. And now we can delete all of this debugging code. Yeah. Now we should be happy. Okay. Event loop, output, server, run the server. Okay. Run the client. Okay. Shit. Okay. So on the server side, everything is okay, but we didn't get the last message. Yeah. On the server side, we didn't see that the client wants to close the connection. So yes, that is wrong. That is wrong. And pipeline tester. Here we have to make some changes. Parser is innocent. Yes. Parser. Yeah, parser. I messed up with the parser. How much work is done in this database? Well, a lot is left, but yeah, we are now adding pipelining so that we can handle requests very quickly. And our model, or the code that we wrote yesterday has this model. The client sends the request, The server processes and sends back the response. The client sends another request. So per connection, we are only processing one request, and that is kind of bad. So what we are doing is, if the client wants multiple fetches or multiple requests, then the client will keep sending on requests, and at the same time client would also be receiving requests. That is pipeline. So earlier it was that the client sends something and stops, waits for the response, sends the next request. But now client just keeps sending requests, and will then just keep receiving responses, and process the responses. So it is now like pipeline. Yes, it is now continuous instead of one at a time. And yeah, like here, we have all of these requests, right? Let's add one more, 4, right? And here, write to, we are writing everything. We are sending all of these requests, and after sending all of them, we are receiving the responses. But it is not working out. Pipeline tester, client, clear, run the server here, and run the new client. Okay, we are getting to the fourth one, but there is a mistake somehow, and I don't get why the client is stopping. The client should not stop. Okay, what do we see? When we see exit, we are saying want to read is false. Makes sense, which does make sense. If the client has said exit, like shut up, I don't want to talk, then we will stop reading. So this is correct. And if there is nothing in the write buffer, then also we will yeah, then we will say we don't want to write anymore. And maybe we can skip that step, and yeah, we can skip that thing there and put it here. If auto reference write equals right. Shit, write is a function. Yes, write buff. We will only write if write buff dot size, if write buffer has something which we want to write. Otherwise, we will say we don't want to write anything, so we want write equals false. We don't want to write anything, so yeah, want write equals false. Cool. Shit. From the write buffer, we yeah, this is correct. This is correct. The way that we are deleting data from the write buffer, this is correct. Yeah, this is correct. Let's also print write buffer now. Std cout write. Yeah. With the search event loop server, run the server, run the client, and okay, we are never going inside the write function, which is shit. We are never going inside the write function. It's kind of messed up. Why are we not going inside the write function? Event loops here in the event loop. Yeah, if you want to read, We are setting that as an option, and if we want to write, we are setting that as an option. That is nice. And then we are polling. Okay. And then we are checking handle except if there is some new request, we are handling that. And otherwise, yes, if the current socket is ready for, maybe the current socket is never ready for writing. But we can write to the current socket. There shouldn't be any problem because write and read are different buffers. If the result and write, then do this. And okay, handle write, but we are never calling this handle write function. No, we are never calling this handle write function, so something is messed up. Cool. So, bro, I have a doubt. Like, how does this database work? Like, are you making a Redis clone or using Redis for the database part? We are making a Redis clone. Yeah, clone. But the main thing is, this is not production grade. The main idea is to do everything by hand so that we understand everything. But the thing is, in the later part, why am I downloading? In the later part, in the advanced topics, we have hash tables, data serialization is something that I would like to learn, but writing hash tables from by hand, I guess we will do this. But yeah, I guess after this first part one, we will I will go back to competitive programming, doing again competitive programming, and I will reach 1600 set, and then yeah, after increasing my rating and learning a bit more in competitive programming, I will start the second part because yeah, timed practice with gap. I will make this database when you make an explanation video of it. Shit. You can start making it right now, and if there is some problem which you don't get, you can ask on the Discord. That would be nice. Explanation video. If you are, don't wait for the explanation video because I might never make it, or it might take a long time. Yeah, so do not wait for that. You can start building, and whatever you don't get, you can ask on the Discord. That would be much better. Yeah, so after this first part, which will probably end tomorrow, I will go back to competitive programming. Yes, let's go. Pipeline requests. Client wants to close the connection, but this is not working. Okay. If we want to close the connection or there is some error and want read is off. Shit. In case of error, we will just, yeah, we will just close the connection. We won't wait. Okay, so if ds poll list fd and fd equal not fd cfd, let's say, is poll list I dot shit, it is s, literally says there s. If uh fd s dot want close, and we want to close, and we don't want to write anymore, and not fd s dot want write. If we want to close and we do not want to write, then we close the connection, or if there is some error with this FTSS. For error, we have to see result bitwise and with error, which is, I guess, pole error. Yeah, pole error. If any of this happens, then close the connection. But the problem is not in the termination part. Problem is somewhere else. For now, I am doing something else. I planned to do it later. Amazing. That will be better because you have to make video for me. I'm thinking of doing it December, so no worry. Yeah, there's no worry. And what is the status of rest? Yes, I've read about memory safety, like references. There are borrow references, mutable references, and these are the rules which the compiler checks. Every value has a owner. Every value has only one owner, or instead of only, should say exactly one owner. And then when master goes out of scope, value is freed. Yep. And yes, there is borrowing. There are mutable references and immutable references. Instead of borrow references, I should call them immutable references. And there are two things here. First is that you can either have unlimited amount of immutable references or a single mutable reference. Yeah, that is one rule. And the second is this. Second is that the scope of a reference, mutable or immutable, starts from declaration and ends on last use. So yeah, that is also kind of crazy. It's a cool concept for memory safety. Yep, it is a cool concept, and you have to be aware of what you are doing and how you are trying to achieve it. So you cannot be a bad programmer cannot write code in Rust. It would be hard. Like there are restrictions and rules, but if you follow it, it will take care of memory safety itself instead of garbage collector. Yep, memory safety at compile time, which is crazy. Every data has only one ownership. Yep, every value data has exactly one ownership. Yeah, that is nice. But this is not nice. Okay. At least I think after making this change, we won't get that infinite loop where the server just went on printing the same thing again and again. We won't be getting that loop, that error, not clear. First, second, third, fourth. But then, why does the server stop after that? Shit. And application process payload. Okay, when exit, then do this. Before doing this, cout read G++ application. Not application does not even make sense. Event 2. Run the server, go to the folder, run the client, and exit. Hmm. Hmm. Yes. Yes, that is nice. That is nice. So what is the problem here? Let's see what is in the right buffer. And yes, the right function is never being called somehow. Just somehow never being called because our socket is never ready to write. But why is the socket never ready to write anything? Stir equals exit. It would be equal to exit. Okay, here is the printed. Okay, because we are never exiting. Client wants to exit. Event loop, servers, and I'm predicting that we will see client wants to exit, and we don't see that shit. Shit. Okay, so there is some serious problem with this. Why is stir never equal to exit? Let's, oh yeah, std, or we have to flush this, flush std out. C++, event loop, server, clear, run the server, go to right, go to the correct folder, client, run the client. Okay, now the client does want to exit. So every message from the client side is going perfectly on the server side, but the client is not either reading. So every message is going correctly, going forward correctly. So, but I think we are never calling this write function somehow. End line. And here HTTP. Okay. Server clear, run the server, go to the right, go to the correct folder, run the client. Okay. And we are never trying to write. So the write function is never being called. Bro is always on YouTube coding. Hello. I cannot understand one thing about Rust. Huh? Skill issues. When most of the APIs Rust deals with is written in unsafe language, so to say C. Yeah. What difference would it make if the wrapper is in safe or unsafe language when the code itself is unsafe? But to write unsafe code in Rust, you have to go out of your way and literally use the word unsafe and create a separate unsafe code block. But this problem would not arise if you are not dealing with other language and you have written the whole thing in Rust. The problem is still, the cause of the problem is the other language, not Rust. Like in Rust, if you have a compiled code, then it will mostly work. Yeah, mostly it will work. It won't panic when except when it is logic bug, which is the case most of the time. Yeah, logic, like you're trying to access something outside of a vector or something, which is not in range, outside a bound. Time, but in some cases it has error, like if you make a mutable reference and a mutable one, well, and don't make changes on the mutable reference, it won't give error. Wait, it will give error You cannot have a mutable reference and an immutable reference at the same time in Rust, right? You cannot have these two things at the same time in the same scope. But rule says that once we have a mutable reference, we cannot make immutable. Yes, you cannot make an immutable run. Yes, you cannot. Like here, error. Y is a mutable reference to X, and we are using X here, and Y is still there. So, yeah, X is now acting as an immutable reference, and Y is the mutable one, and we cannot have them at the same time. We are getting error. So, yep, you are getting error. Why would it give error if the immutable reference is not being used? That variable would be removed from the assembly due to optimization, like dead code elimination. The scope of the immutable reference ends at the last place where the immutable reference is used. So the scope of y begins on this line and ends here. So that is good. We can use x outside of the scope of y, and we are at this line, at this fifth line, y is invalid. Y does not exist. So we can use an immutable reference here. But in this case, y does exist at this line where we are calling x. So there is an error. The thing Rust calls is unsafe. What about that? Yeah, that is the part. C has been so long that almost everything is written in C. Still, that the problem is C, not Rust. Rust is okay. Rust is happy. The problem is C. So it is next to impossible to escape that. So I don't see how to that benefits. If you write the whole thing in Rust, and a lot of companies are doing that. I think Firefox is writing the whole thing in Rust. You can have, bro, it will compile without an error loop. That is the thing. It is not compiling. It is giving us error. No, it won't give. It is giving error right here. Huh? And you can have a different function, say immutable variable, or let's say reference, and this takes in a reference to a string, right? And calls x. Okay, shit. How do we? Shit. This is not the way we find things. Reference to string. Is it okay? Yeah, it is okay. And this will just print the string. Yep. And here instead of this, if we were to call this function with x as a reference, no problem, because here we do not have y, but here we have error. We cannot create a immutable reference while we have a mutable reference. So we are getting error. I'm kind of new to programming and I'm learning Python and C at the same time, so it won't create much confusion, right? I I guess yes, Python is too much English and C is too much computers. So yeah, if you can do it, then it is okay. I need C for college and Python for my own projects. Yeah, just get really good with C. That would be nice. Just to get really good with C, because then you would be able to understand a lot of things, like a lot of low level details, and that is good. Mutable references, takes immutable reference of the variable, you print it to, yeah, that is the problem. But then how does Rust help, and how much code you write in Rust? There is literally millions of code that has been optimized for years. So, okay, what could be the other option? I mean, at least we have something which is fast and does not give memory errors. So that is good. And yes, I'm using a immutable reference, and that is what you said, right? That we cannot, that compiler will compile when we have a immutable reference and a mutable reference at the same time, but it is not, it is giving error. If you don't use it, right, if we don't use it, then it won't, it will compile. So why don't we want to compile it? That is okay. There wouldn't be any problems with this if we are not using the immutable reference. Okay, they tried writing, perhaps still are, and there are more bugs and few performance issues than gains. Core utils. Okay, but then the other option is that you will get memory error and okay, I mean, you just have to judge at the time if there is something worth writing in Rust, right? It depends. Just don't use print and declare both immutable and mutable reference. Okay, let x equals x or z equals x. Still, there is an error. Here we have a mutable. Okay, shit. Okay, is this what you meant? Here we have a immutable reference and here we have a mutable reference and we are not getting error. Why? Because this immutable reference, the scope for this thing, it starts from this line and ends at this line. So yeah, at this line, y does not exist. That is why this is compiling. Yeah, so this is also okay according to the rules because y does not exist on this line. So that is okay. How much memory error did you get? I don't think I get any memory error. Just read my previous comment above, the one where I talked about millions of code. Where is the millions of you cannot yeah, you cannot reply and do that. Shit. Millions. No, no, no. Yeah, millions. Okay. In your code, you are using mutable reference. Mutable reference. In your code, you are using mutable reference. Why? Why is the mutable reference? The print macro takes immutable reference of the variable you pass it to print. Okay, so what is the problem with this? That is what you said. Okay, so if the scope ends there, we can use print just below mutable reference and declare immutable as well. Yeah, their scopes cannot overlap. Here after this, you can say let y equals mutable reference. And this also works because at this line Z, at this line Z is out of scope. Z is like dead. And here you can use, and here you can print it. Y, Y, and printf. Makes sense. Println y, and then let x equals this and println z. This is completely okay. No problem with this. And also there are literally tens of flags and if not hundreds to check for memory leaking and sensations in compilers. Yes, for people who don't have to deal with hundreds of millions of lines of code and see if they make memory error. It is more of a skill issue because I don't think I've ever heard curl having issues. Okay, I cannot say for people who are writing who are working with millions of lines of code. But what I have heard is that no matter how good you are, you will make memory errors. No matter how good you are, how big it is, and how many people use it daily, you would think it would be attacked and exploited pretty frequently, but there are very few. Curl is a very old project, and yeah, the I would say maintainer is pretty cool. Maintainer is Daniel Steinberg is the maintainer for curl, and he's pretty cool. Which are exploited pretty frequently, but there are very few CSVs regarding curl or even FMPEGs. What is the point? But there are still CVEs, right? So yeah, there are still memory errors, and which literally got slower in Rust. Which literally got slower. Shit, curl got slower in Rust. Okay, that is something. Rust was made like because some people had skill issues. Yes, it is also, yeah, you will make memory errors even no matter how good you are. Yeah, and for that people profiting tools and compiler flags. I think having this debate is kind of pointless because I don't know too much of Rust and I am also not a good programmer. And instead, what we can focus on is this thing, fixing this thing, missed, this doesn't work. We are never calling the right function. Yeah, somehow we are never calling the handle right thing somehow. Application side code. Even though when we are processing payload, we are saying turn right equal to true. Okay, and this is our event loop. This is not the event loop. Event loop is here. Yep. Here, if when we are filling this list and if the current socket wants to read, let's say std out wants read, g++, event loop, outside output server, clear, start the server, missed dot slash client. Okay, wants read. Yes, we do want to read. That is amazing. That is amazing. Okay, we do want to read. So are we seeing that the flag that this thing is never ready to be read from? Pull in, pull out, pull out. Handle right. Han handle right, this function. Handle right takes in a connection and does some stuff with it. Right button. Users event loop server here, not Clara server. Run the client and it is running. Yo, especially considering the drama with the Rust Foundation. Pro companies don't care about your language, they just uh, They just their work to be done efficiently. That's all they care about. Profit, the programmer. No matter the language, if the program is bad, they will always write bad code shit. I mean, that's why Python is widely used and in demand. Yeah, using Python. But by the way, Chris Latner prefers Python and he's, I guess, making a library for Python. And Chris Latner is the guy who made LLVM. He made LLVM and Swift programming language. That is nice thing. And I think he was also working or might still be working in Google optimizing their TPU. Yeah, he's one of the best creator of LLVM, Clang compiler, Swift programming language, and MLIR compiler infrastructure. After his PhD, he worked at Apple for 12 years, eventually leading developer teams. Yeah, he's pretty good. Yeah, one of the best. And I do not get why he prefers Python somehow. And yeah, he also has a Python library or maybe a fork of Python, Mojang or something like that. Yeah, I don't remember. Client wants to read and hello from server. Wants read, and then we are outputting this thing. This thing is empty. Okay, this is right. Shit, this exactly. This is correct. This is correct. So we are calling the function to write, but there is some error. The function is not executing. Here, okay. So we are calling this function. So our socket is ready to be to write things at times, but there is some error. Okay, write function, write what? This makes sense. Shit. Okay, shit. This makes sense. Okay. No, shit. This is correct. We want to write everything that is here. Write dot data everything. Okay. Unable to print. Okay. P error. Let's say normal printer so that we will see this and standard output. Want close is true. Want write is also false if there is an error. And the error cannot be interruption error. And error no. Okay, if error number equals interruption error, in that case, okay, there is no loop to continue. Set if error number equals error interruption, then big. Okay, return. We will write the next time. Otherwise, yeah, we don't want to write anything. We want to close this connection and printf written this much percent %d n. Okay. What is read? What read? Okay. G++ output server clear dot slash server dot slash client. Okay, client wants to exit and why are we not written 21 bits? That is nice. We wrote the whole thing, but the server, I think the client is not reading this thing. The client is literally not reading. So that might be the problem. And if we have written, then why are we writing the same thing again and again? We are writing this for the next thing. Okay, the client wants to connect, wants to exit. Because it seems like this is writing application code. A lot of things. Only few programmers work efficiently in all languages. Okay, a debate is going on. Learning language isn't a hard thing. I mean, logic remains the same. Learning a different paradigm might take time. Rust, you could say Rust has its own paradigm or its own way of writing, which is very unique and new. Memory safety at compile time. Put length, yeah, whenever we are generating a response here, server wants to say instead of this, we will say that this is a string. Mhm. String and add to this thing a character called I. And what is I? And I equals 0 and I increases with every D that we do. Yeah. G++, event loop, output server, what's that? Run the server on the right is client. I shit. Okay, shit. For what C++? Yes, this is not what you do. I is not this. I is going to be a character whose initial value is 1. And you don't actually have to typecast. I, okay. Run the server, run the client, and okay. So this is request number 2, 3, 4, 5. Okay, we are writing everything there. It is okay. So the error is here with this thing and not just this, but also why is the server not closing the connection after this point? When the server has responded to all the requests, why is it not closing the connection? Here, after writing the whole thing, yes, when we have written the whole thing, want to Right equals false. Yes, this should be correct. Want to write is false. And when we are here, when we are processing the payload and we see that the client says exit, then we are saying want to read. Oh, I think at this point, the server side code is amazing. Yep. Client wants to close the connection, wants to exit, and the client wants to close the connection. Yes. So we are successfully creating a connection and removing it from the client. So that is very nice. But on the server side, cannot read all the requests. Run the server, a new, cannot read all the requests. Okay, that is kind of crazy. But yeah, the server side code is amazing. The problem is with the client and pipeline tester.cpp. Hello. He hacked AWS 2 days ago. He's hacking YouTube. Today AWS messed up. Yes, AWS messed up. Their internal DNS messed up. I think it has an internal DNS, right? Their DNS server went down. And when they did fix it, because there was a big backlog of requests, they were just unable to process them. And this, I did not do any research. This comes from Fireship. Fireship is amazing. Yep. Okay. What we have to fix is the client side code, which is this. Okay. So we are writing successfully, but we are not reading successfully. Shit. Okay, this is the error that we were getting there. Cannot read all the requests. Okay. N equals read from this thing. We are trying to read. Okay, so we have to debug this read function, I suppose. And we can delete everything else. And yes, this thing, this plugin, Harpoon, guess who? I mean, you might already know, but still, Mr. Prime Agent, Harpoon, why the Prime Agent. Yeah, which is a pretty nice thing. Yeah, this is a pretty nice plugin. We can use this to quickly switch between things. So, bro was having fun. Like this, we can switch between files very, very fast. Like this. Look at this. That is very fast. Blazingly fast. Okay, read from. That is the function which is giving us error on the client side. Okay. Length, parse length on this file descriptor. Okay, it should work. Parse length, while. Okay. Immediately I can see the error. And shit, that was stupid. I think we were getting stuck in this while statement because I was not updating rem. Rem has to be equal to the number of bytes remaining that we have to read. Shit, if that was the main thing. Shit. Pipeline tester, output, client, run the server, which is amazing, and miss, run the client. Okay. Cannot read all the requests. Okay, so shit, there is some other error still. Hmm, I don't like these two lines. This line does not have a new line at the end, and we are seeing a new line after this. Yeah. So we can remove this debugging code from the server, which makes sense. And yep, we do want that client says thing. Nope, we don't want this anymore. We know that the server is writing, so that is kind of cool. Print error, and that is nice. Now we have to do something with this. Okay, so parse length, who is giving us the error? Printf length is %d new line length. Oh shit, length is nothing. Thing is answer. G++ compile the server, which is event output server, and pipeline tester, which is acting as the client. Yes, run the server. Wait, okay, server is running now. Run the client. Connection closed. In shit, I think this message can be better than it is right now. Here, client wants to close the connection. We can say connection with client is closed now. We compile the server, event loop, outside, server, not outside, output as server. Run the server, run the client. Yep, connection with the client is closed now. So yes, on the server side, everything is okay. Server got the first message, second message, third message, fourth message, and then closed the connection. But the client is, yeah, the client is misbehaving. Yo, your UI is really good. How did you make this? Okay, this is Vim. And if you are asking about this thing, this is Oh My ZSH. You can use this, install Oh My ZSH. And yeah, this is the single line. Run this shell script and you will get Oh My ZSH. The download guy? Who's the download guy in your UI? Also the VS, huh? The code editor, new Vim. Okay, if for new Vim you are asking about new Vim, then shit, if you can go to Kickstart actually. Kickstart and Vim. This thing. This is for people who want to write their own new Vim configuration but don't like are just starting to write it, so they can install this and configure things on their own. So yeah, you can use this configuration. And to understand how to use Kickstart, you can watch this video, the only video you need to get started with Neuro by TJ DeVries. And this is like really good video. This is a really good video. And install and custom. Okay, what do you mean by I'm talking about the guy who created download? He meant speed on extreme level. Who created download? There is a guy who created download. Isn't download a thing? Shit. There is a guy who FTP file transfer protocol for downloading was created by Abhay. Shit, Indian? FTP RFC. I think it should also be here. Then there are two different routes. 1985, also known as Tim BL, is an English computer scientist. He created it. What do you mean created? Download. Down. What do you mean created? Download. Shit. No, I didn't add you as a moderator. Is download a software? Yeah, it is impossible to credit a single person with creating the concept of download. Download is a general thing. Download feature on what thing? Like, yeah, is this the guy? I mean, you can write the name of the person who created download. I don't get what you mean by created a download. That is a very general thing. Okay, this shit. Okay, this thing. South Dakota meet the creator Instagram. Creator of downloading. Shit. Uh, Peter Lehan. You meant him. Okay. What did he do? He doesn't have a Wikipedia page. Retired director business. Peter Lihanen. Shit. Why does Pro not have even 500 connections? Shit. 41 years. Technical director and not his projects. Yes, it might be in his projects. A download. NASA. System tracking. Something. Meet Peter, the quiet pioneer behind downloading. Okay, I will have to read about this. What it means for someone to create downloading. What the name from the video? He worked with the guy who created internet. The guy who created internet was Vint Sir. This he was one of the founding fathers of the internet. That is like his name. The father, yeah, is recognized as one of the fathers of internet. He, yeah, sharing this title with TCP/IP co-developer Robert Kahn. And this person now he just gives interviews to people. He even has an interview in some English news, Hindi news channel, Indian news channel, Indian news. Yeah, yeah. He has interviews here on NDTV. Yeah, Peter Lenahan. Okay, I will look into it. What this means for someone to create download, meet the creator of download. This is very funny. Was it the one who created VLC? Didn't charge any money. VLC is open source, like how the media and made it for free. All yep, same guy. Khan's algorithm. That Khan. Wait, what is Khan's algorithm? It is Karp's algorithm. Richard Karp. Is there any specific sequence you recommend from your channel to start with? No. Robert Caro. Toposort. No, not really. I mean, yes. Okay, the videos which are on my channel right now, I don't think they can help you in programming itself, but the main thing that they can help you with is maybe just maybe the way that I'm coding and not what I am coding. Yes, because right now the quality of my videos is not very good. It is just random shit. Yeah, the quality is not very good. And in the future, I will be making better videos. Yeah, I'll be making better videos which I can actually recommend someone to watch. And these videos, yeah, no really order. You don't even have to watch. This is stream, nothing, and they are not recommendable. Yeah. And thank you for watching. Anyways, Tuposort, they can help you programming every day and don't care. So let's go. Tuposort, shit. He used they. Topological sort. I think it might be on CP algorithms. The creator, Khan's algorithm. Yes, shit. I don't know. Person. No, that is the different guy, Arthur Khan. And yes, when I saw your name for the first time, I thought the creator of Kitty is here. Yeah, neither did I. We have to read about graphs. I thought you were the creator of Kitty terminal. Look at his name. The creator, Covin. Kind of the same thing. Yeah, I misread. But yeah, shit. Okay, we have to fix this. It's already 3 hours and 40 minutes. Undefined error 0. The error, like as we have narrowed it down using binary search, the error is here on the client side. We have this max buffer and we are trying to read. And flush CD app. Okay, and yeah, we can keep the server running here on the background and G++ pipeline output or out name output as save as client. Cannot read all requests. Okay, so we are not even going till that part of the code, and yeah, server can keep running in the background. Pipeline tester. Okay, so we are not even getting here. Shit. Cannot read all requests. Okay. We are not printing this line. So let's see. Wait, are we getting in here? G++ pipeline tester. Shit. We can use the this thing. Cannot read all the requests and length was equal to 0. Okay. And compilation time is 4 milliseconds. Okay. So we were unable to read. Parse length. We did print this thing, which means n was smaller than 0. which is not good. And set. Okay, I'll be right back. Wait. Yeah, I used to do that when I was a kid. It is not that difficult. Just remove leaves from tree. Uh, Hello, shit, what happened? No job. Are you working? 25 pass out. You just passed out and no, no job. Shit. Maybe if you make a Redis from scratch and add it to your resume, maybe. Wait, and my own, yeah, everything is cool. So we are unable to read, and the server is running. That is cool. Write all error. Yeah, parsing. Okay, why are we unable to read? From this file descriptor, we want to see the error that we are getting. What kind, if any smaller than this, an error number is not equal to error interrupt. Then do this. Okay, yeah, compile this. Cannot read. Okay. So error number, no, shit. We don't do, yeah, this would not be equal to this. We have to take bitwise and of these two things. Okay. Okay, oh, we are always getting interruption error somehow. Okay, somehow we are always getting interruption error. Why? Somehow we are always getting interruption error. Interruption error. Always. Read from FD. That is nice. We were able to write everything onto this buffer, but we are unable to read somehow. Here can read. Here is motivation. I am 27, 20, 23 pass out, and I'm still unable to crack it job. Shit. That is too much pressure. Yep. Keep grinding, don't give up. Yep, keep grinding. You already know something like Mun or Java, or is it the first thing that you are doing? Okay, me. I've done some things in MERN and not Java, but in MERN I did the Harkrit course, but not in a very good way. Yes, that is very sad. But I would okay, I might not be in the position to judge because I'm just in college and I'm nowhere close as old as 27 years old. But my way of thinking is that if I'm in a bad place, that is because something I did is wrong. Yeah, something somewhere I messed up. Not that the world is bad, and I'm not saying that you are saying that the world is bad. I'm just putting out my perspective, which might not even be needed. I know both Spring Boot and Fast API stack. That is nice. Feels a bit bad, but I think it is worse if I get placed now and knowing any dev. It is worse if I get placed and now not knowing any dev. Just because you won't be able to do anything. Shit. Get enough yapping, I would say. Read buffer, max buffer. Okay, we are unable to read and we are always getting interruption error and we have to chat GPT. Shit. Retracted, something happened. We are getting interruption error. Mhm. We will turn off the interruption error bit, which means not take and with it. We can take interruption error number equals error number or with interruption error. So now we know that that particular bit is on, and now we'll take XOR with interruption error. Now that bit is off. Okay, still. Okay, so we are actually getting interruption error, which we'll have to fix. Okay, we'll have to debug. Are you following? Okay, who is Ria? Also, I got confused, but the thing is, bro, you should not think like that. I have seen a few people not knowing much and getting plays. Yeah, that is just how some things, yeah, the world is not fair. You get knowledge once you start working and doing it daily. Yep, I'm getting knowledge like this, and yeah, whatever however it goes. And shit, this is not working. And I would have to debug this, which I will do off the screen now using ChatGPT because interruption error. Why would I be getting interruption error? And this has been very long enough, 3 hours and 53 minutes. Yep. Key value server, that would be the next thing. And I would, yeah, I would do my best to complete this thing off the stream today. And so that we can just begin with key value pair tomorrow. And that would be nice. And then we will get back to competitive programming. Shit. Guts, Mr. Guts, right there. Bye. Hello. Yo. Shit. And yep, that would be it for today. Thank you for being here and